Hey guys, this is Mrs. Teagues. I am going to try and do a quick video on how to do Lewis dot structures. I realized that I don't really have a PowerPoint that talks about this way because I kind of did it on the fly with you guys. So the first step is you need to know the total valence electrons, not charge, but valence electrons. So you add all these up. So carbon is 4, each hydrogen has 1, and then the F has 7. So we have a total of 14 for this structure. The next thing you have to remember is what's going to be in the center. Well, from our rules, we know that carbon is always in the center, or you could say hydrogen's never in the center, or it's the one with the least valence electrons that's not hydrogen. So carbon fits the bill for those. So I'm going to put carbon in the center, and I'm going to put a hydrogen, and a fluorine. Hydrogen. This is really difficult to hold the phone and draw at the same time. Okay, so now I need to make sure that I've got all 14 showing. So each line is going to be worth 2. So I've got 2, 4, 6, 8. Now I'm going to put the rest of the electrons in pairs on the outside first, if I can, and then anything left over would go onto the middle. Well, none of these hydrogens can take any more electrons, so I'm going to put them on fluorine. So if I've got 2, 4, 6, 8, that's 10, 12, 14. And I know I'm done because I've gotten to the 14. So this is the structure. That's what this would look like. For the next one, PBr3, again, I need to know the total valence electrons. That's that top number, the group number, ignoring the 1. So P is 5, each bromine has 7, you get a total of 26. I know that P is the middle because number 1, it has the fewest valence electrons, but also it's only one of them. So if you get to something that there's only one of them in the problem, then that one has to be in the middle. So you draw P, and I'm going to draw the 3 bromines around it. Br. I'm sorry if I'm all over the place with this. This is really tough. I'm sure there's a better way to do this, but whatever. You guys get this. All right, so now I have 2, 4, 6 drawn. Again, I'm going to put them on the outside first. That's 8, 10, 12, 14, 16, 18, 20, 22, 24, and I need to put the last set on P now. Now I know that everybody's happy because everybody has access to 8 electrons, but let's just double check. So each line is worth 2, so that's 2, 4, 6, and that finishes it up with 8. So P is happy, each bromine is happy, and this is the appropriate structure for that one. For this guy, this one's a little trickier, so I accept several things for this, but I'm going to show you how it's supposed to be drawn. So again, I did my totals, but you have to take into consideration that this has a charge. So -1, so you got to add 1 electron in. You've got 1 s, 1 c, 1 n, and then add 1 extra electron brings us up to 16. If you somehow figure out that you have an odd number of electrons, you probably did something wrong. All right, so here we have C is going to go in the middle because of the rules. Carbon's always in the middle. It also has the fewest number of electrons, and then I'm going to put the others next to it connected with 1 bond. I've got a nitrogen and sulfur. Okay, so I've got 4 electrons showing. I need to get up to 16, so I'm going to put them on either side. So 6, 8, 10, 12, 14, 16. Now, I know that I'm not done because carbon's not happy. These two guys may be, but carbon is only connected to 4 electrons right now, which makes him super upset. So we're going to move some things. Now, I'm going to be pretty lenient on this and say, well, if you want to move somebody from nitrogen and you want to move one from, or a pair from sulfur, that's fine. That's usually what students do. Technically, though, they're supposed to be, let me see if I can do this. It's supposed to be both moved from nitrogen, so we've got a triple bond here. I don't expect you to know that that's how it has to go. So there's actually 3 different ways you could have done it. You could have done a triple bond with sulfur and carbon. That's really not what it likes to do, but I would accept that because it follows the rules. Or I would accept a double bond here and a double bond here with 2 lone pairs on either one. Okay, so as long as you're moving it appropriately and I still have 16 electrons showing, that's fine. Let's just, for funsies, do formal charge. Do you guys remember formal charge? So formal charge is you take the valence electrons minus dots and lines. So formal charge of nitrogen, nitrogen has 5 valence normally, and it's got 1, 2, 3, 4, 5 dots and lines on it. So formal charge of nitrogen is 0. For carbon, carbon has 4 and it's connected to 4 lines. So 4 minus 4 is 0. And then for sulfur, sulfur has 6 valence electrons and it's connected to 1, 2, 3, 4, 5, 6, 7 dots and lines. So 6 minus 7 is -1. So this sulfur has a -1 charge. Isn't that fun, guys? Last one. We have a total valence of 12 with 2 hydrogens, 1 carbon, 1 oxygen. Carbon always goes in the middle. I'm going to connect it to the 2 hydrogens and 1 oxygen. So I'll put 1 oxygen here. I will put hydrogen here, hydrogen here. And now let's make sure that we've got 12. So we've got 2, 4, 6 showing. Hydrogens can't take any more electrons, so I'm going to put the rest on oxygen. 8, 10, 12. Now I need to make sure that everybody's happy. I know my hydrogens are happy and technically oxygen's happy, but carbon's not. So we're going to move this lone pair right here. And we're going to make a double bond with carbon and oxygen. I still have the 12 showing, but now carbon has a double bond, and that makes him happy with 2, 4, 6, 8. All right, guys, listen, let me know if you want to see any more, or if there's any other structures that are vexing you, or if you have any other questions. I'm going to try to make some more videos on each of the notes that we've done for this unit so you don't forget. And take care of yourselves, guys.